Good morning, dear students. Welcome back to our lesson of chemistry, which is the last lesson of chemistry, that is structure of atom. See, in previous lesson, we have talked about mole concept from lesson number 3. So, atoms and molecule, everything about atoms and molecule we have learned in the previous chapter. So, now today onwards, we are going to start the new chapter, and which is the last chapter of the chemistry of class 9th. Which is actually the basic lesson, and these 4 lessons will help you for your class 10th chemistry. So you will have to study them in detail. So this is the last lesson, that is structure of atom, how the atom is designed. So students, actually what is atom, what is molecule, we have already learned in the previous chapter, that is atoms and molecules. But then too we should learn, as the name of the lesson is structure of atom, so it's our duty to learn, or it's my duty to tell you about atom once again. So what is atom? Atom is the smallest indivisible, invisible, and indestructible part of the matter. What is matter? You are knowing the smallest particle of the any matter is called as an atom, that we have learned. Atom is said, previously it was said that it is smallest, invisible, indivisible, indestructible part of the matter. Then another definition means, another way we can say that, we are knowing students, the atom is still divisible particle, but it was discussed later, it was later on come to know to the people that atom is still divisible. But before it was said that atom is the smallest, invisible, indivisible, indestructible part of the matter. Atom is also called as the smallest entity, or at smallest or basic or fundamental entity of the atom, of the is called atom of the element. Okay, smallest entity, or basic or fundamental entity, or basic fundamental smallest entity of the element is also called as a atom. See, here there is an example. See, this is one file, or this is complete element which is made up of the sodium. Okay, this complete element is of the sodium. So sodium, it's of sodium, so small particles you can see. This gold spherical structure, you can see this spherical structure, these are nothing but your atoms. And as this complete sheet, or this complete whatever it is of the sodium is made up of sodium, so whole this element which is present over here is composed of what? The smallest entity of this element, that is called as a sodium atom. As this complete sheet is composed of the sodium, so that this complete sheet is composed of a small particle of the element, that is sodium atom. Then another also we can take, this is aurium. Aurium means your gold. Okay, gold ornaments we used to prepare our jeweler, means jewelry. Okay, in a jewelry shop we get a jewelry which is made up of the gold, but the Latin name of this gold is aurium, so I have written its formula, small unit formula, that is aurium. Okay, so this whole element, or this aurium foil, or the element is composed of what? It is nothing but a small particles called as a atom. And as it is gold foil, it is made up of the aurium atom. Okay, I hope you understand. And here in both the cases you can see the shape of this atom is what? The shape of the atom is spherical. Okay, and the particles present in the atom are called as the subatomic particles. Students, in previous year also you are knowing there are few subatomic particles into the atoms. Which are those? We will learn about them. Okay, so there are mainly 3 particles of atom. What are those? Neutrons, protons, and electrons. Okay, out of it neutrons and protons are present into the nucleus. Okay, and the nucleus is composed of neutrons and protons. So these particles of the atom are called as, say, the neutrons and protons. Neutrons and protons are called as a nucleons. Ons means what, student? Ons means particles. Okay, so neutrons and protons are made up of nucleus, or neutrons and protons together called as a nucleus, and these 2 particles are called as a nucleons. Ons means particles. So these neutrons and protons, what are the charges they have? You are knowing, students, neutrons are chargeless particle. They don't have any charge on them, right? And protons have positively charged particle. Protons always have a positively charged particle which is present into the nucleus. Neutrons are chargeless particle. They don't have any charge on them. So protons are positively charged particle. How much charge the protons have? Protons have plus 1.6 into 10 raised to minus 19 coulomb. Okay, these protons have charge plus 1.6 into 10 raised to minus 19 coulomb. Coulomb is the unit of the charge, electrical charge. About coulomb you will learn in your next class. In class 10th you will learn in electricity chapter about everything about coulomb. But it is, you can, till now you can keep in mind that proton is positively charged particle, and it contains it has a charge that is plus 1.6 into 10 raised to minus 6 minus 19 coulomb. Okay, at the same time electrons which are revolving around the nucleus into their orbits, so these electrons are always negatively charged particle. This is all about atom I am talking about. Actually there are various models of an atom, but as we are talking atoms, so let me finish about everything about atom. So there are three subatomic particles, that is neutrons, protons and electrons. Neutrons, I said you, these are chargeless. Protons are positively charged, which have a charge plus 1.6 into 10 raised to minus 19 coulomb. At the same time electrons which are revolving around the nucleus are always negatively charged, and it has also same charge but charge is negative. So its charge is minus 1.6 into 10 raised to minus 19 coulomb. So plus 1.6 into 10 raised to minus 19 coulomb and minus 1.6 into 10 raised to minus 19 coulomb is 0. Okay, positive and negative makes it 0. So that atom is electrically neutral, that I shall let you know. SI unit to measure charge is called as a coulomb. Coulomb is the SI unit to measure the charge. So here coulomb is written, that I said you will learn in class 10 about this coulomb. Okay, you will have to solve the sums also based on the coulomb, but till here you can keep in mind that it is the SI unit to measure the charge is called as a coulomb. Now atom is said to be electrically neutral. Why? See, the nucleus is composed of what? Neutrons and protons, and the mass of the nucleus is equal to how much? As we have seen just now, that protons are positively charged and electrons are negatively charged. Okay, now here neutrons and protons, which is combinedly called as a nucleus, and its mass is what? 1.67 into 10 raised to minus 27 kg. Okay, it's very small number. As I said you, atom is too small. It's not possible us to see the atom by any microscope, by high definition of microscope. It is not possible because it is too minute. Atom is the too minute that we are unable to see it with the naked eyes, as at the same time with other instruments. Understood? So it has a very negligible size. At the same time it has very negligible mass. This number is very negligible, students, because see, it's minus 27 kg. 1.67 into 10 raised to minus 27 kg is the mass of the nucleus, which is composed of neutrons and the protons. And how much is the mass of the electron? Actually all the mass of the atom is accumulated or concentrated at the nucleus. Means whatever we say na, atomic mass. Okay, atomic mass, whatever we say, that atomic mass means the mass of the electron and the mass of the neutron and the proton. Okay, electron is not considered, which is very negligible. So electron has mass how much? 9.1 into 10 raised to minus 31 kg, which is really very small number. I hope you understand the mass of the nucleus is always greater than the mass of the electron. Okay. So next, mass of nucleus is considerable. Means the whole mass of the atom is concentrated at the center. The mass of any atom is concentrated at its nucleus, because atomic mass is considered to be the mass of the proton and the neutron. So electrons have very negligible mass, so it is not considered. I hope you understand. So this is just a structure of any atom. Till now we are knowing and we are studying about this structure. That is how it is designed. You can see positively charged protons are accumulated here. Chargeless neutrons are present here. Chargeless, so it does not have any charge, so it will be written like this. So positively charged protons are present, chargeless neutrons are present, and it is called as a nucleus. And electrically means sorry um, negatively charged particles are revolving in its shells or in its orbits are called as a electrons. Okay, I hope you understand all these things. So neutrons, who has discovered this? कोणी शोध लावला न्यूट्रॉन्स प्रोटॉन्स आणि इलेक्ट्रॉन्सचा? So neutrons discovered by James Chadwick. Okay, it's the name of the scientist. Neutrons are discovered by James Chadwick. Protons are discovered by Goldstein. These protons are also called as a canal rays. This is the name of the protons. Protons are discovered by Goldstein, and the name of the proton is also called as a canal rays, means protons are also called as a canal rays. And electrons discovered by Thomson, J.J. Thomson. Electrons are also called as a cathode ray. Neutrons do not have any other name. I hope you understand. Neutrons are discovered by the James Chadwick, which there is no other name for the neutron. Then protons are discovered by Goldstein. The other name for the proton is canal rays. Electrons are discovered by the Thomson, and electrons are also called as a cathode ray. Suppose we will talk about sodium. Okay, sodium has atomic number 11. Means what, students? 11 positive 11 protons are present, chargeless 11 neutrons are present, and 11 electrons are also moving in its orbit. 12 neutrons are present here actually. 12 neutrons are present. Neutrons are 12, not 11. 11 protons, 12 neutrons which do not have any charge. Protons have positive charge and electrons have negative charge. In any atom, number of electrons are always equal to the number of protons. Number of electrons and number of protons are always equal. See here, you can see. So that atoms, this sodium atom has 11 electrons which are negatively charged, and at the same time 11 protons are present which are positively charged. So in any atom, number of electrons are always equal to the number of protons. So that atom is electrically neutral because it will not have any charge. Same number of protons and same number of electrons are, so same number of protons and same number of electrons are present, so that atom is electrically neutral. Now what is meant by atomic number? Atomic number is denoted by letter Z. Students, keep in mind always atomic number is denoted by letter Z. What is the definition of the atomic number? The total number of electrons or protons in atom of a given element is called as a atomic number. As I said you, number of protons and number of electrons are always equal in any atom, so that the definition of the atomic number can be the total number of electrons or protons in atom of given element is called its atomic number. Here example is sodium, which has atomic number 11, which is denoted by letter Z. What is meant by mass number? As I said you, all the mass of any atom is accumulated at its nucleus. So what can be the definition? Can you guess of mass number? Mass number is denoted by letter A. The sum or the addition of total number of protons and neutrons is called its mass number. Atomic mass, still you are knowing. Last chapter also I said you atomic mass. See, atomic number and atomic mass number is different. Atomic number is what? Either number of protons or electrons in an atom of a given element is called as atomic number. But what is atomic mass number? As mass is accumulated at the center of its nucleus, so that the addition or the sum of the total number of protons and neutrons is called the mass number. So only sodium has 11 protons, and how many neutrons are present? 12. So 11 plus 12, how much? 23. So atomic mass number of the sodium is what? 23. I hope you understand, which is denoted by letter A. So I hope the concept of atomic number and atomic mass number is clear for you. See, students, there are various scientists. I said you, J.J. Thomson has discovered the electron, right? I said you. Then Goldstein has discovered, what is the discovery who has done just now? I said you. So according to them, the atom was different actually. Later on, Bohr's model we considered, or the standard model of an atom is considered of the Bohr's model. But before him, various scientists have studied for the structure of atom. Who were there? So various scientists were there. Goldstein was there, Thomson was there, Rutherford was there. But actually they failed to recognize the proper model of an atom. Then who was the winner in them? Actually they were inspiring from the others work. Okay, various scientists were there. So one was being fail in that, so other was making a use of previous knowledge and trying to study more. So various scientists were there. So first scientist were there, his name was the J.J. Thomson model of an atom. Its history is quite interesting because he said that atom is looking like a watermelon. You can see here, when we cut the watermelon into two pieces, at the same time you can see the red portion into the watermelon, right? And in the red portion, the small seeds are also present, which are of black color. So he resemble the model of an atom with the half cut watermelon. Means he said that the all the portion which is the edible part, we eat that red part, and the seeds we throw it out. So what he said, the edible part of this watermelon is positively charged. Means all the positively charged particle is what? The its edible part. And the seed like structure is, he said that it is electrons are embedded. Means what he said, electrons are embedded into the protons or into the edible part. He gave the, means he compared his atomic model with the plum pudding, Christmas pudding, and at the same time watermelon. You are knowing, student, the structure of watermelon. When we cut into the half, this red part, he said that it is positively charged particle, and the seed like structure, he said that it is electrons. Means he said that electrons are embedded into the positively charged particles. I hope you understand. You can go for in your textbook also, you can go back and you can read that topic, so that you will get it more better. Red edible part of the watermelon is considered to be positive part, which is called as a positively charged sphere, and black seed is considered to be negatively charged particle, he said that. And the total magnitude of positively charged is always equal to the total magnitude of the negative charge. But actually, when we had gone ahead, we came to know the structure of the atom is not like that. He failed to design a proper structure of an atom. It was his assumption that atom would be like watermelon or the plum pudding. But he was fail. He was not sure about the proper structure of the atom. I hope you understand what he said. When we cut the half watermelon, then the red edible part, he considered that it is positively charged, and the small seed like structure, he said that this is negatively charged, and the total magnitude of positively charged particle is always equal to the total magnitude of the negatively charged particle. So this is all about Thomson's model of an atom. And tomorrow's lecture we will talk about Rutherford's model of an atom and Rutherford's gold foil scattering, gold foil alpha particle scattering experiment. Thank you.